all you need to know about the properties of determinant. So this is like a list of formulas that you can use to learn and understand everything that you need to know about determinant and the rules that you can use to solve. There's a specific video made just for this section that will give you some idea of how we came up with this solution. If you recall, we use this formula to find the inverse matrix. I'm just going to highlight a few things that I've noticed. The formula that we're using on this side is the same as this formula that you see here, equal to the term over the adjoint of A over the determinant. So this is what we call adjoint. So the adjoint, it's written as adjoint adjoint method, which is the adjoint method. And what I wanted to highlight is what we call adjoint. Okay, what do we see inside adjoint? It's actually what you see here. This is the what we call adjoint. All of this, we call it adjoint. So in simple term, I can say the adjoint of A equal to the cofactor transposition times I, the unknown. And what you should know is what is inside the cofactor. So the truth is it's actually the adjoint of A is actually equal to all of this here. This is what we see. We start by looking to by finding the minor and then looking for the cofactor, and then we move to the transposition of the matrix. This is what you see here, and all of this is actually the adjoint times, you're going to multiply it by this okay, so it will be a multiplication of the unknown times minor cofactors and transposition of the matrix times this unknown, then we get the adjoint of a matrix. This is like a definition of what you should know about this formula. So adjoint is actually what you see here. So this is actually the adjoint of a matrix. Okay, so now we're going to start what we are supposed to start to be covering. We'll see the properties of adjoint. Okay, let's say for example this is the adjoint of A. It's actually equal to the matrix n -1, and it's like the size of matrix. And let me give you another example. Okay, this is another property, so it will be adjoint of A will be equal to A m -1 square. Okay, let me give you another one so then you can see you can actually understand what is going on. So we got ourselves, so it's another adjoint okay, and what we're going to get here, it will be A n -1 to the power of 3. Let me give you another formula. So let's say, for example, we need to find this adjoint. So it's gonna be the constant minus 1, the power of matrix minus 1, adjacent of A. And then let me give you something else, which would be, let's say this for example. This will give us A n minus Z A. Okay, let me give you one more. -1 equal A -1 okay. So this is this was just give an idea of all the properties that you can get from an adjoint matrix. Okay, I'll add another one here. So let's say you are tasked to find the adjoint of A. This is like lower case equal to A to the power of n. Okay, let me give more formulas. So let's say, for example, this is what we have. A, the answer to this will be adjoint A times A. We can just reverse them, which will give us determinant times identity. Next, we're going to see a adjoint of a transpose. The answer to this will give us adjoint A transpose. Next, let's say we have to find the adjoint of A B. So it will be adjoint A times adjoint B. Okay, these are just what we got. Now let's see, this is like a inverse matrix. Let's see some properties that's for inverse matrix. Okay, so we got this formula, inverse matrix of another inverse matrix equal that matrix. Okay, as we have seen, inverse of a transpose matrix equal to -1, the inverse of that matrix transpose. Okay, let's see something else. Maybe this form, -k. So this will give us 1 over k, inverse of that, times the inverse of that matrix. Only if k is not equal to 0. Okay, so now let's see another property. So this one is A times 2. When we have two matrices to the power of inverse, so this is what we get. Okay, now let's see A, B, C inverse, and this will give us and A. Okay, now let's see this other property. Let's say, for example, we had A times, so let me just call it times and the answer to that will be an power n negative inverse of 1 all the way down to A. So this is what we'll get. Now let's see this form, and for this form we'll get A 1 negative inverse times n. Okay, and condition is n has to be part of the z positive form. Okay, so this is what we have. I'm going to move this on to the inverse formulas. So here is another formula for inverse. This is how we can represent it. Okay, alright, so now let's see another properties called transposition that we can use. Okay, so let's see the transpose of another transpose will give us just it's going to cancel out. Now let's see if we add, for example, A plus B transpose, this will give us A transpose plus B transpose. Now we got ourselves this one. So K as a constant, we're not gonna apply the transposition to it, so we're going to end up with this form. Okay, let's see another form. Transpose, there's a multiplication, so we'll end up with B times A transpose. Now let's see when there's a determinant of A to the power of T. The determinant will be A. So just to give you an idea, now let's see a transpose of an inverse matrix, and this will give us A to the power transpose minus 1. Okay, and what you should know is you can either represent a transpose like this or like this. It's just the same, it has the same meaning. Okay, so there are some more properties like the transposition of a identity matrix will give you that identity matrix. Okay, and the transposition maybe for a zero matrix will always give you that zero matrix. Okay, so let's see, we need to find the transposition. So the answer to this will be A transpose, B transpose, C transpose. There is one thing, it will be the other way around, so we're going to start with C transpose times B transpose times A transpose. Always reverse them. And if it was negative A negative B transpose, the answer to this will be A transpose negative B transpose. So this is what we have. Okay, these are the formulas, the properties that we can have. In summary, these are the properties that we can have. Okay, these are the properties we can have, and